What is the network stack and why does it fail? Imagine trying to send a letter across the world. You need a clear address, a reliable courier, and a safe route. Computers do the same thing when they communicate over networks. The network stack is like a set of layers that organize how data travels from one device to another. It is built into the operating system, which is the main software running your computer or phone. This layered system makes sure data is sent correctly and reaches the right destination. The network stack follows models like the Open Systems Interconnection model or the TCP/IP model. The OSI model has 7 layers, each with specific jobs. The first 2 layers, physical and data link, handle the actual transmission of raw data over cables or wireless signals. They also detect errors and manage local network communication using MAC addresses. The third layer, the network layer, is responsible for routing data packets between different networks using IP addresses. The fourth layer, the transport layer, makes sure data arrives intact and in order, using protocols like Transmission Control Protocol and User Datagram Protocol. The top 3 layers, session, presentation, and application, manage how devices connect, translate data, and run services like web browsing or email. All these layers work together to keep your network running smoothly. The network stack is stored in the operating system's core, called the kernel, and also in user space through various protocols. When you open a web page or send an email, your device uses this layered system to handle all the steps needed to get your data across the internet. But sometimes, the network stack stops working properly. This can cause your internet to slow down or stop altogether. Failures can happen at any layer. Hardware issues like a broken network card, damaged cables, or faulty routers can disrupt the physical and data link layers. If your IP address is set wrong or your routing table is incorrect, the network layer can't find the right path for your data. Protocol errors, such as lost packets or missequenced data in TCP, can cause delays or missing information. Operating system bugs or driver problems can also crash the network stack or make it unresponsive. Security settings like firewalls or network policies might block certain ports or protocols, stopping connections from establishing. Problems at the session layer can prevent devices from creating or maintaining a connection, leading to timeouts. Application issues, like a misconfigured web server or email client, can also appear as network failures. Different operating systems have their own ways of building and managing the network stack. Windows, Linux, and macOS each have unique designs and troubleshooting tools. For example, Windows users might use command prompt tools like ping or tracert, while Linux users might use ping or traceroute. These tools help identify where the failure is happening, whether it's a hardware problem, a configuration mistake, or a software bug. Understanding which layer is causing the problem is key to fixing it. If you cannot reach a website, it might be a network layer issue. If you can ping the server but cannot load the web page, the problem could be at the application layer. Troubleshooting involves checking hardware connections, reviewing network settings, updating drivers, or adjusting security policies. In the end, the network stack is a vital part of how devices communicate. When it fails, it can be frustrating, but knowing how it works helps you find the right solution. Whether it's a simple cable fix or a complex software update, understanding these layers makes troubleshooting much easier and more effective.